Hi, this is Rosemary teacher from St. Thomas School. I am going to teach Maths for academic year 2021. Today we start chapter 2 Polynomials. What is meant by a polynomial? An algebraic expression of the form p of x equal to an x raised to n plus an minus 1 x raised to n minus 1 plus etc. a1 x raised to 1 plus a0 where a0, a1, a2 etc. an are constants and an not equal to 0 is called a polynomial in one variable x. A0, A1, A2, etc. An are called the coefficient of x raised to 0, x raised to 1, x square, etc. x raised to n respectively. N is called the degree of the polynomial. Each of an x raised to n, an minus 1 x raised to n minus 1, etc. a1 x raised to 1, a0 is called a term of the polynomial p of x. If a1 equal to a2 equal to etc. an equal to 0, then p of x equal to a0 and is called a constant polynomial. That is, if a polynomial consisting of only constants. For example, you can say p of x equal to 3. It is a constant polynomial. Here, if a0 equal to 0, then p of x is called a zero polynomial. What is meant by a monomial, binomial, trinomial? A polynomial consisting of one term is called a monomial. If it is having two terms, called binomial. And with three terms, it is called a trinomial. Now, a polynomial of degree 1 is called a linear polynomial, degree 2 is called a quadratic polynomial, and degree 3 is called a cubic polynomial, and degree 4 is called a biquadratic polynomial. A degree of constant polynomial is 0. Now we will move to exercise 2.1. Question number 1. Which of the following expressions are polynomials in one variable and which are not? State reason for your answer. Question number 1. 4x square minus 3x plus 7. In this polynomial, we are having three terms and the variable present are x and the powers are whole numbers. Therefore, it is a polynomial in one variable. Question number 3. 3 root t plus t root 2. In the first term and the second term, t is the variable. But we look into the power. In the first term, t is having the power 1 by 2. Therefore, it is not a polynomial. The reason is the power of t is 1 by 2, which is not a whole number. Now, question number 2. Write the coefficient of x square in each of the following. Question number 1. 2 plus x square plus x. We are having a term with x square and the coefficient of that term is 1. Therefore, the coefficient of x square is 1. Question number 4. Root 2x minus 1. In this polynomial, we don't have the term x square. Therefore, the coefficient of x square is 0. Question number 3. Give one example each of a binomial of degree 35 and a monomial of degree 100. A binomial is having two terms. So you write any polynomial with two terms having the power of the variable as 35. So I have written here y raised to 35 plus 7. Next, a monomial of degree 100. Monomial is having one term. So you take any polynomial with one term having the degree 100. So I have written here it is x raised to 100. Question number 4. Write the degree of each of the following polynomial. Question number 1. 5x cube plus 4x square plus 7x. The highest power of the variable x is 3. Therefore, the degree of the polynomial is 3. Question number 4. Given 3, it is a non-zero constant. So, the degree of this polynomial is 0. Question number 5. Classify the following as linear, quadratic and cubic polynomials. We have already discussed in that question number 1, x square plus x. It is a polynomial having the power 2. Therefore, it is a quadratic polynomial. Question number 4, 1 plus x. Here the variable is x having the power 1. Therefore, it is a linear polynomial. Question number 7, 7x cube. It is having only one term and the highest power of x is 3. Therefore, it is a cubic polynomial. Now, we will move to zeros of a polynomial. The zero of a polynomial p of x are the solutions of the equation p of x equal to 0. That is, if it is a polynomial with variable x, the value of x is called the zero of the polynomial. The number of zeros of a polynomial can be more than 1. For example, a linear polynomial is having 1 zero. Quadratic may be having at most 2 zeros and etc. A linear polynomial has 1 and only 1 zero. The zero of a polynomial may be 0. For example, p of x equal to 3x. To get the zero of the polynomial, we have to take p of x equal to 0. That is 3x equal to 0. X equal to 0 upon 3, that is 0. Therefore, 0 of p of x is 0. It is not necessary that the zero of a polynomial is 0. Sometimes it may be other constant numbers. We will move to exercise 2.2. Question number 1. Find the value of the polynomial 5x minus 4x square plus 3 at x equal to 0, x equal to minus 1, x equal to 2. For finding the value of the polynomial, let p of x equal to 5x minus 4x square plus 3. Value of p of x at x equal to 0. That means we are replacing the variable x by the given value 0. Therefore, p of 0 equal to 5 multiplied by 0 minus 4 multiplied by 0 square plus 3. That is equal to 0 minus 0 plus 3. That is equal to 3. Therefore, the value of the polynomial at x equal to 0 is 3. Now for the same polynomial, value of p of x at x equal to minus 1. Here you have to replace the variable x by minus 1. Therefore, p of minus 1 equal to 5 multiplied by minus 1 minus 4 multiplied by minus 1 square plus 3. That is equal to minus 5 minus 4 multiplied by minus 1 square is plus 1. So it is minus 4 multiplied by 1, that is minus 4 plus 3. That is equal to minus 9 plus 3, that is equal to minus 6. So the value of the polynomial p of x at x equal to minus 1 is minus 6. Then question number 3, value of p of x at x equal to 2. Same way we are replacing x by 2. Therefore, p of 2 equal to 5 multiplied by 2 minus 4 multiplied by 2 square plus 3. That is equal to 10 minus 16 plus 3. That is equal to minus 3. Therefore, the value of p of x at x equal to 2 is minus 3. Exercise 2.2, question number 2. Find p of 0, p of 1 and p of 2 for each of the following polynomials. We are doing the first sum, that is py equal to y square minus y plus 1. It is a polynomial in variable y. So given p of y equal to y square minus y plus 1. At y equal to 0, p of 0 will be 0 square minus 0 plus 1, that is 0 minus 0 plus 1, that is equal to 1. We have to find p of 1, so replace y by 1. So p of 1 equal to 1 square minus 1 plus 1 equal to 1 minus 1 plus 1, that is equal to 1. Therefore, p of 1 is 1. Now p of 2 equal to, replace y by 2, you will have 2 square minus 2 plus 1, that is equal to 4 minus 2 plus 1, that is equal to 3. Therefore, the value of polynomial py at 2 equal to 3. Now, question number 3. Verify whether the following are zeros of the polynomial indicated against them. In that, take question number 3, that is p of x equal to x square minus 1. The values of x given are 1 and minus 1. We have to check whether 1 and minus 1 are the zeros of the given polynomial. For that, we are replacing x by 1. You will have the polynomial p of 1 equal to 1 square minus 1, that is equal to 1 minus 1, that is equal to 0. Now, you are getting p of 1 equal to 0. Therefore, 1 is a 0 of the given polynomial p of x equal to x square minus 1. Now, same way we find p of minus 1, that is equal to minus 1 square minus 1 equal to minus 1 minus 1, that is equal to 0. Since p of minus 1 equal to 0, minus 1 is also a 0 of the given polynomial p of x equal to x square minus 1. So you can write the conclusion as 1 and minus 1 are the zeros of p of x. Now we will move to question number 5. P of x equal to x square is the given polynomial. You have to find the value at x equal to 0. So replace x by 0, you will have p of 0 equal to 0 square, that is equal to 0. So 0 is the 0 of polynomial p of x. Now question number 8. P of x equal to 2x plus 1, x equal to 1 upon 2. So replace x by 1 upon 2. You have p of 1 upon 2 equal to 2 multiplied by 1 by 2 plus 1. That is equal to 1 plus 1 equal to 2. Since we are not getting p of 1 by 2 equal to 0, it is not a 0 of p of x. So 1 by 2 is not a 0 of p of x, that is 2x plus 1. Now, question number 4. Find the zero of following polynomials in each of the following cases. In that question number 1, we have p of x equal to x plus 5. To get the zero of a polynomial, we have to equate p of x equal to 0. That is x plus 5 equal to 0. From that you will get x equal to minus 5. Thus, 0 of x plus 5 is minus 5. Question number 2, we have p of x equal to x minus 5. To get the 0, p of x equal to 0, that is x minus 5 equal to 0. Therefore, x equal to 5. Thus, 0 of x minus 5 is 5. Question number 3, we have p of x equal to 2x plus 5. To get the 0, you have to equate p of x equal to 0. That is 2x plus 5 equal to 0. 2x equal to minus 5. Therefore, x equal to minus 5 upon 2. Thus, 0 of 2x plus 5 is minus 5 upon 2. Now, the questions that we have discussed from exercise 2.1 and 2.2, you have to write it in the notebook and practice it. The questions that I have marked in exercise 2.1 and 2.2, you have to do it as homework. Thank you.